In this section, we're going to be working on hypothesis testing for proportions. Remember that proportions mean what percent of the population has a certain characteristic. So we'll start out again with the steps for doing these. It's going to use a z-test, just like it did with confidence intervals. So we're using a z-test for a proportion P. Step 1. We got to do some verifying. Verify that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Remember, n is sample size, p is the the population proportion, and q is the population proportion that's not p. Remember, 1 minus p gives you q. So remember that this, when we talked about this for a confidence interval, that this means that the sampling distribution, which was p hat, can be approximated by normal distributions. And that's important for us because we want to be able to use z-scores. Step 2, state h sub 0, h sub a, and identify the claim. Step 3, specify the level of significance, which is still alpha. Step 4, determine critical values and shade rejection regions. Remember, we might have a left-tailed test where we have a z-score here and this area is alpha. We might have a right-tailed test with a z-score critical value and this area is alpha, or we might have a two-tailed test with two z-scores, one positive, one negative, where those areas are alpha over 2. Step 5, find the standardized test statistic. So we're going to be using z-scores, but we're using population proportion and sample proportion. So it's a little bit different formula. It's z equals p hat minus p divided by square root of p times q over n. Okay, I want to just take a moment to go over what all of those things are. P hat is the sample proportion. P is the population proportion, and that's what's being hypothesized. P is, again, the population proportion. Q is 1 minus P, and N is sample size. Step 6, we're going to decide to reject h sub 0 if z is in the shaded region. Otherwise, do not reject h sub 0. And step 7, good old interpret. Interpret the decision in context of the original claim. And that's that very specific language that we look back to our chart and make that decision. So we're just going to do 2 examples. This one's from page 391, and then the next one's going to be from page 392. A research center claims that at most 75% of U.S. adults think that drivers are safer using hands-free cell phones instead of using handheld cell phones. In a random sample of 150 U.S. adults, 77% think that drivers are safer using hands-free cell phones instead of handheld cell phones. At alpha equals 0.01, is there enough evidence to reject the center's claim? So step 1, we have to see if n times p is bigger than 5. Well, let's kind of figure out what all of the numbers are in this problem. That 0.75, that's the population proportion, because they're claiming that 75% think that's true. So that's going to be p, which means that q is 1 minus 0.75, so q is 0.25. In a random sample of 150 U.S. adults, so that's n is 150, 77% of those think drivers are safer using hands-free cell phones. So that's going to be the sample proportion, which is p hat, so that's 0.77. If we need q hat, that'll be 1 minus 0.77, so 0.23. And then alpha is 0.01. Lots of numbers in this problem. Step 1 in our process says that we have to verify that n times p is greater than 5 and that n times q is greater than 5. So I have to do 150, so n times p greater than or equal to 5. 150 times 0.75, which is going to be a number I'll look up in a second, and n times q has to be greater than or equal to 5, so 150 times 0.25. So 150 times 0.25 is 37.5, which is bigger than 5, and 150 times 0.75 is 112.5. So both of those are good. Then we can move on to h sub 0 and h sub a. The claim was that at most 75%, so 75% or fewer. So that'll be p is less than or equal to 0.75. That's our claim, and that's our null hypothesis, which means h sub a would be p is greater than 0.75. We already identified alpha is 0.01, so we'll do our critical region. H sub a goes to the right, so I know I've got a right-tailed test. And my alpha is 0.01, so that area is 0.0100, which means I'm going to look up 1 minus 0.0100, so 0.0900 to get that z-score. So I need table 4. I'm looking up 0.0900. Somehow I think I subtracted that wrong. 1 minus 0.01. That I did. 0.9900. Now we'll look up 0.9900. That'll be better. The closest is 0.9901, which is 2.33. So that z-score is 2.33. And then I'm on to my standardized test statistic. This is like the complicated formula. It's z equals p hat minus p divided by square root of pq over n. So we've got p hat 0.77 minus p 0.75 divided by square root of PQ, so 0.75, 0.25, divided by N, which was 150. square root of 0.75 times 0.25 divided by 150. And then 0.77 minus 0.75 divided by that number. So that gives me a standardized test statistic of 0.57. Since 0's in the middle, my 0.57 is going to be in that clear region, which means I do not reject H sub 0. When I do not reject H sub 0, and H sub 0 is my claim, I've got this, do not reject. There is not enough evidence to reject the claim. So then I would say at the 1% level of significance, which means 1% of the time I might be wrong. At the 1% level of significance, there is not enough evidence to reject the claim that at most 75% of U.S. adults think drivers are safer using hands-free cell phones instead of handheld cell phones. All right, just for good measure, we will do another problem. This one is going to be about a humane society. A humane society claims that 30% of U.S. households own a cat. In a random sample of 200 U.S. households, 72 say they own a cat. At alpha equals 0.05, is there enough evidence to reject the society's claim? So we need to go through all these steps again. We need to, first, I'm just going to start by writing down all my numbers, what I've got. Claims 30% own a cat, that's P. P equals 0.30, which means that Q is 1 minus 0.30, so 0.70. Random sample of 200 households, so N is 200. 72 say they own a cat. So that's not giving us P hat, but it's telling us that P hat would be 72 out of 200, and then we can divide that to get that P hat is 0.36. And they have given us that alpha is 0.05. So we need to go through our steps, verify that N times P is bigger than 5 and N times Q is bigger than 5. So we have 200 times 0.3, which is definitely going to be bigger than 5. 200 times 0.3 is like 60. Yep. That's greater than or equal to 5. And then 200 times 0.7 is 140, which is bigger than 5. So we're good to go on that front. Then let's figure out H sub 0 and H sub A and which one's our claim. The Humane Society claims 30% own a cat, so that's P equals 0.3. So that will be H sub 0. That's our claim, which means H sub A is P is not 0.3. That's telling me that I'm going to have a two-tailed test, which means I'm going to have two critical values. And remember that when you have a two-tailed test, each of these areas is half of alpha. Alpha was 0.05, so each one is 0.05 divided by 2, which is 0.0250. So I'll look up 0.0250 on my standard normal distribution. Oh, there it is. It's negative 1.96, which means this critical value is negative 1.96, and this one is positive 1.96. And then I calculate my standardized test statistic. So Z would be P hat minus P. P hat was 0.36 minus P, which was 0.30, divided by square root of P times Q, 0.3 times 0.7, divided by N, which was 200. Square root of 0.3 times 0.7 divided by 200, and then 0.36 minus 0.3 divided by that number. So our standardized test statistic is 1.85, which falls right there. So we do not reject H sub 0. Since H sub 0 was our claim and we're not rejecting our claim, we would say there is not enough evidence to reject the claim. So we would say at the 5% level of significance, there is not enough evidence to reject the claim or to reject the Humane Society's claim. That 30% of U.S. households own